Let's talk about the symbols here, okay? So when you see a cell like that, this is the positive side, that's the negative side. Notice that the positive side, since it's so positive, is bigger, okay? A battery literally just means a battery of cells. Typically, lead-acid batteries are 1.5 volts per cell. So this would be like 1.5 volts, that'd be 3 volts, right? But, you know, I have 23 volt cells, you know, or something like that. Don't worry about it, right? Okay, and an AC supply, this is providing alternating current, which is sinusoidally varying. This is a switch. Voltmeters, you have to understand that they have a resistance of infinity. Like current cannot flow through them. Ammeters allow current to flow through them with no resistance. Now, in reality, real ammeters have just a little bit of resistance, and real voltmeters have millions of ohms of resistance. So it's almost like they're not there, but not quite. Okay, let's look at, okay, so there's a voltmeter. We've got resistors are like this. In the US of A, we do resistors this way. Let me just say for PowerPoints and stuff, it's a lot easier to draw this one, so I'm good with that. A variable resistor, right? You turn the knob and, you know, it changes the resistance. This is a lamp. In the US of A, we use this for a lamp, you know. That's like a valve or something like that. Potentiometer, this is like, we can put 5 volts there. And we can go 0 volts there, and in the middle we get 2.5 volts. It's just like the electric field mapping lab, right? You put the probe in halfway between the plates, and there it is, right? Okay. This is a light-dependent resistor. That's all I know about that, right? Thermistor, this is temperature sensitive, right? A transformer, we'll look at these things, right? And they actually look like that. This is like an iron core. A heating element. I think it's a face. Okay. A diode, and by the way, the current can flow this way. It cannot flow this way, right? And then a capacitor, right? Electrolytics look like this, but evidently IB doesn't want you to know about them. This is the positive side, the negative side. All right. And then when we do this stuff, we've got a lovely analogy that we'll use. You've got to think about a constant pressure pump. We've got some pump that maintains some pressure here. We've got a resistor. A resistor is like a constriction, right? The flow rate is just like the electrical current. The pressure is just like voltage. The more pressure you have, the more current you have flowing. And, you know, we'll use this analogy. It's useful when it's useful. It's not useful every situation, right? You know, kids will point out, well, what if there's a hole in the pipe? Well, if it's a water pipe, the water will leak out. If there's a nick in the insulation of a wire, the electrons don't flow into the room, and that's because of course, the air is a really good insulator too. Okay, so anyway, yeah.